Got to hit the broadcast.
Okay.
You'll have to excuse me because I have no makeup on. It,
Oh,
it,
don't.
it's a
Don't.
rainy, cold day here, and I'm sitting in the living room with slippers and pajamas.
Oh. All right. Well, let me pull up mine. Okay. Now, from what I gather, it seems pretty straightforward. I mean, I didn't have too many troubles with this particular one.
The only trouble I had was that, when they went through and watched it, and this is why it took me so long, is because I went through and I did it, and then I was watching the video of the answers and kind of going through, and then all of a sudden he was coming up with different answers than I was, and so what was kind of a bummer is that they're doing it in Excel, even though it says in the video SPSS, he's not showing an SPSS. And I went through and plugged in all the numbers into SPSS to try to come up with the histogram and the mean and all of that. And my mean was different than their mean.
Oh,
So I had to go back then and redo it with, I manually calculated out the mean and, and redid all the problems.
oh my gosh.
So, um, so that was the only area in which I had trouble. Is it seemed like
Well,
SPS SPS.
the problem that I ran into personally from here was, um, let's see, I'm gonna go back through it. Um, was understanding part four of the very last one, the second one. Um, understanding the formulas, like where he gets they put on the answer key, compute the test statistic. What is the formula to be used? Recall our test statistic with a z-score. Writing down the general formula. Input the numbers you will use. So the mean is 47, and the z-bar. I guess I just need to see that formula, how they come out with a 0.209. Make sure I understand it correctly.
Yeah, that's where I got stuck, and so then I actually, well, hold on. Now that I'm looking at it, hold on a second, because I got distracted when I
Are
guess
you
I
are you
guess I
this?
still I didn't get the right answer.
Okay, that must have, I had the same problem then.
I got 0.0697 for the z-score. What did you get?
I erased it. I don't even know what I had. But I was getting frustrated because I don't know how they were coming up with zero point zero 0.02 or 0.209. Uh, I have to go back to it.
Okay. I know what I did. I know what I did wrong. Okay, hold on a minute. I didn't hit enter.
You just didn't hit enter as far as.
Yeah, I'm using my computer calculator, and so when I have to do a square root and stuff, if I if I don't hit um, enter, then I mistakenly take the total that I'm seeing as the
That,
answer,
that
not.
may have been my problem too, because further down, or in the next lesson, in 10, I had to keep going over and over because I kept making just enough minor errors that I had to be very careful and then compare it, and then I'm like, okay, because I'm using the calculator off my phone. It seems to be the handiest as far as maybe I'm just making bad habits, but
Yeah. So let's see. And I don't know why they didn't get a minus. Uh, okay, so I just did it when I corrected my stuff. And I got, so 46.73 is the mean of the sample. And minus the population mean, which is 47, divided by 5, which is the standard deviation, divided by the square root of 15, which is the number of the population, or of the sample size.
let me do the math real quick again. I typed it out as you said it, and I just want to make sure that I'm on the right page. Okay, well, it came out that time.
Okay. So then we get the p-value of 0.8344.
Right. Well, now I can finish it because I have the correct answer. I can understand it easily by putting that in the applet. And we reject the null hypothesis because it's under.
No, and this is where I get confused. We failed to reject.
It's the opposite. That's right.
Yeah, because our p-value is greater than the level of significance. So that means we keep the null hypothesis.
Okay. And then it asks, what action do you suggest the realtor to take based on your statistical conclusions?
I would say no action. I wouldn't make any changes.
Yeah, it seems to be pretty close to the average anyway, so.
Yeah. Well, and I was thrown off on the QQ plots. Like, I caught it from the video. I didn't catch anywhere that if it wasn't a large population that you need to make a QQ plot.
No, but it's in one of Ten's videos. It goes back to the QQ plots. So I think I might have meshed it with 11, but it does go back to the video on a QQ plot. I actually ended up Googling QQ plots and fully understanding, because I missed that question on the test.
Oh,
Understanding there was the one question with the QQ plot.
yeah, yeah, yeah. If it was in a normal linear fashion or not linear.
Yeah.
Okay. All right. So you want to just take the test?
Yeah, let's do it. Let's just be done with it.
You're so done, huh?
I have so many other classes and so much else on my plate, and I'm speaking to the choir, but it's like,
Yeah, you're hitting that mid-semester. What have I done to myself? So what other classes are you taking?
I'm taking a healthcare admin leadership class.
Uh-huh.
I'm taking my last religion class.
Uh,
Uh,
Religion is a lot of busy work.
oh, it is. It's a lot of busy work, and then I just needed to fill the extra couple of credits. So I showed as a full-time student, and so I've got another class on inner victories, and it's just a lot of busy work. It
Yeah.
almost feels like check marks, like, okay, I just got to get it done.
Yes, yes.
You
I
know.
only I only have three classes. I have medical terminology, and I have intro to public health, and luckily they haven't been too much busy work. Public health is a lot of reading. I feel like, gosh, I spent all day at work reading. I,
Yeah.
I have a lot of waiting time, where I'm waiting in between sequences or waiting for a patient. And so I have a lot of reading time I can do, but um, yeah, but otherwise, this is my big thinker class.
Yeah, my leadership class is reading. It's all just tons and tons of reading, and it's almost book reports and all these great books that I don't have time to really enjoy. I would
Yeah,
really like to sink my teeth into some of them, but I don't have the time to. And we had to pick a book off a list, and I picked the wrong book. It's 521 pages.
oh no.
Oh, and it's called Thinking Fast and Slow, and I don't have time to think slow. I've got to be really quick with my reading. I wish I could take more time with it, but maybe later, maybe someday.
I hear you. Kudos to you for taking a full load. I couldn't. I
Well,
There's just no way. I would be like you. I'd be feeling like I'm sinking.
yeah, with this class, this is the one it's the miss. It's like, okay, well, it's going to be the give me the grade, and as long as I pass, I'm going to be okay, because I'm nearing the end of a bachelor's degree, and I don't have time to worry about it. I've got other stuff on my plate.
You're all, I don't have time for this.
Oh, it's such the wrong attitude, and oh gosh, I know. And this is being recorded, so this is great.
All right. I don't think anybody's. I think ours are always at the tail end, and nobody's looking at us.
That's probably true. That's probably true. All
You're
right, let's
left
yeah.
off. And, okay, so I completed. Yes, I actively participated. Yep, would be only the two of us.
You and me.
A
Number
hypothesis test consists of two hypotheses, the null and the alternative. Which one represents the status quo is the null.
null. Yeah. Which hypothesis involves equality?
The null.
That's null.
The p-value is the probability of obtaining a simple statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true? The null hypothesis.
Again. Okay. Suppose the null hypothesis to mean equal equals 10 uses relation answer 6 through 8. Which of the following represents the alternative hypothesis for two-tailed test?
It would be the mean is not equal to
Equal. Okay. Which of the following represents the alternative hypothesis for a left-tailed? And that would be greater. Greater?
It would be the mu is less than 10. And we can look that up, but I'm pretty certain because left means the tail's going off to the left. And how I've always remembered it is because I made this when they were talking about with the left skewed and the right skewed, is the mean higher than or lower than the median?
Oh, yeah. And then that's how you figured out the left or right.
Yeah, because if you look at the arrow, if I put the word mean first, then the arrow pointed to the left or the arrow pointed to the right, depending on the skew. And that's how I've remembered this. But so I think this one is the mu would be less than 10, but let's double check it.
Because that means I have the opposite wrong, because number 8 will be the opposite probably, so I better double check it real quick. Make sure you're right. I'm sure you're right.
Well, I don't want to be. I'm going to check.
Yep, you're right. Right, and then that leads us to number greater, because right-tailed is greater.
Okay.
Right?
Let's see. Which of the following represents the right-tailed test? Would be, yeah, the mean would be greater than 10.
Okay. The outcome of a hypothesis test is determined by comparing the p-value, level of significance, or A views this information for 9 and 10. Which information would have failing to reject the null hypothesis?
Failing to reject. Okay, if the p-value is greater than the value to the significance, we would fail to reject the null hypothesis. That's the last question that we just answered.
Yeah.
I think that's what we just answered because we got it.
Yeah, it's just exactly 7 and 8. 9 and 10. So greater and then less than.
Yeah, which relation result in rejecting the null hypothesis would be the opposite. If this p-value is small, we reject the null.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned the true mean is actually higher than this, used for 11 and 12.
It would be greater than, the average claim amount is greater than 1,500.
It's trying to understand this,
higher than this.
Yeah.
which of the following would be the appropriate null hypothesis that the average claim amount is equal to 1,500. Hold on a second. Hey, honey. Yeah, I'm sorry. My son's home, and I love his guitar playing, but he says he's bored. He's
Come
playing
take a statistics test.
guitar in my kitchen, and it's like, I can't think. The insurance company randomly selects 40 claims and calculates a sample mean of 1650. Okay. So, the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes. Do you know why?
Because it's greater than doesn't this go back to 30, being over 30 being.
Yeah, it's a large sample, so then it would be a normal distribution. And it would be the central limit theorem is what.
Yeah, okay. Which of the following is the test statistic as defined in this lesson?
I think it's,
Z bar?
yeah, X bar.
Or, yeah, X bar. The historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypotheses. She will use this significance. Okay, so we got to find the Z-bar.
Okay, so 144 minus
150. Are you getting -9 for the z-score?
Okay, what did you get for your z-score?
-0.9.
No, I got minus 1.4999.
144 minus 150 is -6. And you put that on top, and then you're taking $40, which is the standard deviation, divided by what are you putting on as your bottom number to find the z-score then?
So you've got 40 divided by the square root of 36.
Right. Let me do my math again.
I got that as, hold on a second here. Let me go back. So I got 14 divided by 36. So I got the bottom number to be 6.667. So hold on a minute. 40 divided by 4 equals. Yeah, so it's going to be 140 minus, sorry, 144 minus 150
Which is -6.
divided by 6.667 equals, oh, wait a minute. Okay, 0.8999. Is that what you got?
Yeah, I'm doing it on my phone and I'm getting just -0.9.
Yeah,
So,
that would be rounded off.
okay.
25, 7 equals, okay, wait a minute. 144 minus 150 equals, divided by 0.667 equals, yeah, 88999. Okay, so then let's just plug that into the minus 0.8999. Okay, back to the question.
So are we still on 16?
16, so 0.900.
Right.
Okay. What is the p-value associated? What is the p-value associated? Okay, so she's saying less than 150. So I have a p-value of 0.184.
Yes.
4. Okay, and then what was the
What inference? Would you reject it or fail to reject it?
fail to reject? Because the p-value is greater than the alpha. Isn't that what we just answered above?
Yeah. There are two types of errors. Which one involves rejecting the null when the null hypothesis is true? So if it's true, it's negative, it's type 2.
Hold on a second.
I'm thinking that. Wait.
Um,
One. Okay.
that's a type 1.
Yeah, I just run my cheat sheet.
A researcher decided that instead of using a level of significance 0.05, he would use 0.01. So he decreased. The probability of a type 2 will increase. Because he decreased the probability. Isn't that correct by going from 0.05 to 0.01?
Yeah.
Which means the probability for type 2 will increase.
Let me double check on that one. Because I keep getting them switched, so I gotta double check again. And type 2 will increase. It drops, it goes up. So it's gotta be a type 2, and so down we go up. So I think it's the probability of a type 2 error will increase. What did you say?
That the probability of a type 2 error will increase.
Okay.
Because they're inversely related to each other.
Okay.
As the probability of a type 1 error increases, the probability of a type 2 will decrease. Right. Conversely. So now the last question is, I'm not sure that I understand that.
0.05, compute the probability of committing a type 1 error.
I think that would be.
Okay, so if we don't want to make a type 1 error, we're committing, just choosing, you're actually doing type 1 error. If we want to reject the null hypothesis, this is a type 1 error. If we want to reject the null hypothesis, we want to say 0.0. I think it's kind of tricky, but is it pretty clear cut just saying, would you pick 0.05 or 0.01?
I was thinking 0.05 because that's what it's given to us. Hold on just a second. I've got a. I gotta respond to a text from work. Okay, I was looking for the descriptives of the alpha score. So how do we decide if the p-value is small enough to reject the whole? We need a way to determine if there's enough evidence. Level of significance designated by alpha. We will use the same decision for all hypotheses. If the p-value is less than alpha, we reject the null. Conversely, if the p-value is greater than alpha, we fail to reject the null. Level of significance alpha must be chosen prior.
Are you pulling from the book?
Yeah. Assuming the null hypothesis is true, the level of significance alpha is the probability of getting a value of the test statistic that is extreme enough that the null hypothesis will be rejected. In other words, the level of significance is the probability of committing a type 1 error. So it says, so like the most, so we choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is 0.05. This is equal to 1/20th.
Right.
So when the null hypothesis is true, there is a 1 in 20 chance that it'll be rejected at the 0.05
level of significance. Okay, so you're on 4.5. Type 1 and type 2 errors. Okay, so I think you're right. I think it is 5.
So do we put 0.05 or do we put 1/20?
It doesn't say percentage.
And it doesn't let me put in a division sign. So 0.05.
Yeah, because I just tried doing a percentage and it doesn't let me put that in, so it's got to be 0.05. Right?
Sure. All right, ready to hit send?
Yeah, let's go. Oh.
What did we miss? Oh, the z-score. I'll have to read that better.
Oh, 15.
15 and 16 is what we got wrong. I don't understand why we got 16 wrong.
Oh, we got 16 right. It was negative 0.900.
I didn't put the negative.
Oh, shoot. Didn't we just have the reverse problem last quiz?
Yes! I hate
making for your test, cause oh shoot.
So 15, did you get 15 wrong?
15 wrong. I put X bar. Okay, so which of the following is the test statistic as defined in this lesson? It should have been Z.
Z.
X bar.
You got what, 95%?
Yeah.
All right. Well, good. Then I will continue to study 10 and 11.
Okay, let's try and do 10 tomorrow morning. Let's just work on 10.
Okay.
Let's just plan on 10. If we get further than that, that's awesome.
Okay.
If not, we'll have water cells another day.
This is what, try to get together on Saturday and get 11 done?
Yeah, let's do 11 like later on.
Okay.
Later in the evening. We'll see how we're doing tomorrow morning. 10 goes quick.
Okay.
Well, we're at least going to be, we'll get our homework done. We'll at least be in the right week.
Yeah.
Okay.
Right.
Well, have fun tonight, whatever you're doing, and enjoy your no school.
I got to go drive to Chico, which is about an hour away, so that I can go get my daughter's phone that she left there at a party she wasn't supposed to go to.
So Chico, that's close to, is that close to Citrus Heights?
No. Other end of the state.
Oh, okay.
Citrus Heights is down in Southern California, and Chico is up in Northern California.
Oh no, Citrus Heights is just outside Sacramento.
No, you're right. No, so it's actually north of there about 2 hours.
Oh, okay.
Yeah.
All right.
I forgot. I forgot that Citrus Heights was a suburb of Sac. I was thinking it was a suburb of LA.
Yeah. All right.
Yeah.
Well, pop me up tomorrow and see where you're at, and I'll go over it again. You know, it doesn't hurt me at all.
Okay.
And later.
All right. We'll do 10. I'm gonna hang up with you and do the homework. So do we need to post this one? Did you say you posted in 9 or in?
Go ahead and post it under. Go ahead and post it under mine, Because he already gave me an A for it after I had posted by mistake. I think it's an automatic. So
Yeah.
post mine, and then that way I don't show that I've got this duplicate problem. We can explain it to him later if we need to.
He knows. He knows what's going on with us. So.
All right.
All right. All right. I'll talk to you later.
I'll talk to you tomorrow. All right. Bye.